Water. It's everywhere we look, isn't it? It's in the air we breathe, the rain that falls from the sky, the oceans that cradle our continents. We're practically walking, talking bags of water. It seems so ordinary, so commonplace, and yet, it holds the keys to life itself. But how well do we really know this fundamental substance? Sure, we know it's 2 parts hydrogen, 1 part oxygen. Get ready to dive deep, my friends, because today we're exploring 10 mind-blowing facts about water that will leave you thirsty for more. We often hear about the vastness of our oceans, right? How they cover over 70% of the Earth's surface, how they hold 97% of the planet's water. But what if I told you there's another ocean lurking beneath our feet? An ocean hidden within the Earth's mantle, locked away in rocks hundreds of miles down. Scientists discovered this subterranean reservoir using seismic waves, those ripples of energy that travel through the Earth. This hidden ocean, trapped within a mineral called ringwoodite, could hold 3 times the volume of water in all the surface oceans combined. It's like something out of a Jules Verne novel, a secret world beneath our feet. This deep earth water, slowly cycling up through plate tectonics and volcanic activity, might be the source of our surface water, constantly replenishing what we have up here. It's a humbling thought, isn't it? That something so essential to life as we know it could be originating from the depths of our planet. Okay, strap in for this one because we're about to get a little weird, a little quantum physics on you. We all learned in school that water has 3 states: solid, ice, liquid, water, and gas, steam. But what if I told you there's a point where water can exist in all 3 states simultaneously? It's called the triple point. Picture this. You have a special chamber where you can precisely control the temperature and pressure. You lower the pressure to a near vacuum, and carefully adjust the temperature to exactly 0.01 degrees Celsius. The water in the chamber starts to boil furiously while simultaneously freezing solid and evaporating into a gas, all 3 states, coexisting in perfect equilibrium. Let's talk about something a little closer to home, something you might have even experienced yourself. Have you ever noticed that sometimes a pot of hot water seems to freeze faster than a pot of cold water, even though that seems to defy logic? Well, you're not imagining things. It's called the Mpemba Effect, named after a Tanzanian student who observed this phenomenon while making ice cream back in the 1960s. Now I know what you're thinking. Are you telling me hot water can freeze faster than cold water? That's crazy talk. And you'd be right to question it. After all, shouldn't hot water have to cool down to the temperature of cold water before it starts to freeze? And yet, under certain conditions, the Mpemba effect has been observed and documented. Some believe it has to do with the rate of evaporation, with hot water losing mass faster, leading to a quicker freeze. Others point to convection currents, dissolved gases, or even the unusual properties of the hydrogen bonds in water. The bottom line is, we don't have a definitive answer yet, but that's the beauty of science, isn't it? There are always mysteries to unravel, questions to ponder. For a long time we thought of water as something unique to Earth. After all, it's the only planet we know of with vast oceans teeming with life. But as we've turned our gaze outwards, exploring the cosmos with increasingly powerful telescopes and robotic probes, we've discovered something amazing. Water is everywhere. Take Mars, for example. Our red neighbor might seem dry and dusty on the surface, but beneath the Martian soil, scientists have found evidence of liquid water, perhaps even vast aquifers. Then there's Europa, one of Jupiter's many moons. Europa is covered in a thick shell of ice, but beneath that icy exterior, scientists believe there's an ocean of liquid water, possibly twice the volume of all Earth's oceans combined. And it's not just planets and moons. We've found water ice in comets, those icy remnants from the early solar system. Water, it seems, is not just essential for life as we know it. It's a fundamental building block of the cosmos. Let's talk about something you're probably familiar with, especially if you live in a place that experiences cold winter's ice. It's slippery, it's cold, and it has a peculiar habit of floating in your water glass. But have you ever stopped to think about why ice floats? Why doesn't it just sink to the bottom like a rock? It all comes down to a rather peculiar property of water. You see, most substances contract or shrink when they freeze. They become denser in their solid state. But water? Water dances to its own tune. When water freezes, its molecules arrange themselves into a crystalline structure that's actually less dense than liquid water. If ice sank, Lakes and oceans would freeze from the bottom up. Fish and other aquatic life wouldn't be able to survive in the cold, dense water at the bottom. The entire ecosystem of our planet would be vastly different. Snaking its way through the heart of South America, the Amazon River is a force of nature unlike any other. It's the lifeblood of the Amazon rainforest, the largest rainforest on Earth, and it carries more water than any other river in the world. To give you an idea of just how massive this river is every single second, the Amazon discharges an average of 209,000 cubic meters of water into the Atlantic Ocean. That's enough water to fill an Olympic-sized swimming pool every 0.2 seconds. The Amazon River Basin, the area of land drained by the river and its tributaries, is absolutely massive. It covers an area roughly the size of the contiguous United States, and plays a crucial role in regulating the Earth's climate. This vast network of rivers and streams acts like a giant sponge, absorbing rainfall and slowly releasing it over time. The Amazon River is a true natural wonder, a testament to the power and importance of freshwater ecosystems. We often think of ourselves as solid beings, but the truth is we're more like water balloons with bones. That's right, our bodies are made up mostly of water, and it plays a vital role in keeping us alive and functioning. Just how much water are we talking about? Well, it varies depending on your age and body composition, but on average, an adult human body is about 55 to 60% water. Think about that for a second. Over half of you is water. It's in our cells, our blood, our organs. It helps to regulate our body temperature, transport nutrients, flush out waste products, and lubricate our joints. Newborn babies are about 78% water, which is why they have that soft, squishy feel. But as we get older, that percentage gradually decreases. It's a reminder that our bodies are constantly changing, adapting, and evolving throughout our lives. We often think of water as a gentle, life-giving force, and it certainly can be. But water also has a hidden power, a patient, relentless force that can shape the very landscape of our planet. Take the Grand Canyon, for example. This vast chasm carved by the Colorado River over millions of years is a testament to the erosive power of water. It all starts with a trickle, a tiny stream of water flowing downhill. Over time, that trickle becomes a stream, the stream a river, the river a raging torrent. And as the water flows, it carries with it sediment, sand, and rocks. These abrasive particles act like sandpaper, slowly wearing away at the rock below. Have you ever taken a sip of water and considered the journey those water molecules have been on? It's mind-boggling when you think about it. Those molecules could have been dinosaur drool, rain in the Amazon, or part of a glacier during the last ice age. Water is constantly cycling on Earth, evaporating from oceans and lakes, forming clouds, falling as rain, and flowing back into the sea. So that glass of water you're holding, it contains molecules that are billions of years old, older than the dinosaurs, older than the mountains themselves. It's a humbling thought, isn't it, that something as simple as a glass of water connects us to the vastness of time and space. We often take the Earth's climate for granted, but maintaining a stable temperature on a planet that's constantly bombarded by solar radiation is no easy feat. Luckily for us, Earth has a secret weapon: water. You see, water has an amazing ability to absorb and store heat. It takes a lot of energy to raise the temperature of water, and it releases that heat slowly. This is why coastal areas tend to have more moderate climates than inland areas. The oceans act like giant heat sinks, absorbing heat during the day and releasing it slowly at night. This helps to regulate the Earth's temperature, keeping it within a range that's suitable for life. Water vapor, the gaseous form of water, also plays a crucial role in regulating the Earth's climate. It acts like a blanket, trapping heat and keeping our planet warm enough to support life. So, there you have it. 10 mind-blowing facts about water that prove it's far more than just a simple substance. From its hidden depths beneath the Earth's surface to its presence in the furthest reaches of space, water continues to surprise and amaze us. So, the next time you take a sip of water, remember the incredible journey those molecules have been on, the countless wonders they've witnessed. Be sure to subscribe to FactQuest and comment below. And never lose your sense of curiosity, because there's always more to learn about the universe and the amazing substances that make it up.